All right, good morning. Welcome back to Calculus 2. We are looking at the series from n goes from 1 to infinity of n factorial squared over 2n factorial. So for this one, because we have factorials, I would say that my first go-to is going to be the ratio test. So again, what we're going to do is we're going to look at a n plus 1 over a sub n and take our limit as n goes to infinity. Okay, and then we're going to see if my limit, I'll call that L, is less than 1, then we're going to converge absolutely. Okay, if L is equal to 1, then we get a inconclusive result. So inconclusive, can't really say anything about it. The test kind of fails. Do something else. And if L is greater than 1, then we diverge. Okay, and because we're dealing with the fact that these are L and absolute values, even though this is all going to be positive. We need to carry the absolute values in there. When we make our conclusion, we have to remember the fact that we have absolute values. So that's why it's a converge absolutely. Okay. So I've got my helper here. He's looking for breakfast. Okay. So here's what we're going to do. Okay, look, turn the kid around for you, but we're going to go. Okay, go bother somebody else. Okay. All right, so here's what we're going to do. We have n plus 1 factorial squared, okay, divided by 2n plus 1 factorial, okay, divided by, here we have n factorial squared over 2n factorial. We're going to have to do, so we applied the ratio test here. We're going to have to do a little bit of what's going on here, okay? So with this n plus 1 factorial, and we have to square it, it's going to be kind of hard. So we have n plus 1 times n factorial, and I'm going to leave the squared right there, okay? And then we end up with 2n plus 2 factorial, and we'll go ahead and deal with that one as well. Okay, again, on the bottom, we've got n factorial squared, 2n factorial. Okay, so let's go ahead and deal with the 2n plus 1, 2n plus 2 factorial. So we have n plus 1 and factorial squared. These are multiplied. So in this case, we can't apply the square to both of these because they're times, not plus. If they're plus, we can't do that. Okay, but since they're times, if I had like 5 times 2, and these were squared, I could say that's 5 squared times 2 squared. Okay, and that's how that would work, right? We'd have 5 times 2 is 10, 10 squared is 100. We have 25 times 4, it's also 100. So that's how that's going to work. Okay, here we have 2n plus 2 times 2n plus 1 times 2n factorial, all divided by n factorial squared over 2n factorial. Okay, let's go ahead and invert and multiply in order to clear up this fraction business here. So we have 2n factorial over n factorial squared, top and bottom, 2n factorial over n factorial squared. Okay. So there's a lot of stuff that's going to cancel. Mostly the bottom of this fraction is going to go away. That was kind of the whole point of this. So here we have n plus 1 squared times n factorial squared. Okay, I just distributed that square, not really distributed, but I applied the square to both of the terms that were multiplied together. And then we're going to be dividing by, okay, here we have 2n plus 2 by 2n plus 1 by 2n factorial, and then we're multiplying this by 2n factorial. Let's put ahead parentheses around that, divided by n factorial squared. Now, here's why we applied the ratio test, was because a lot of this stuff cancels off. Okay. And now what we have to do is we have to apply the limit, right, as n goes off to infinity of n squared plus 2n plus 1. I just multiplied this out really fast by squaring it. And then here we're going to FOIL this piece out. So we have 4n squared. Here we have plus 2n plus 4n. So we have 6n. And then we have plus 2. Okay, as n goes off to infinity. I'm just going to go ahead and multiply by 1 over n squared on top and bottom here, because that's the easy way to deal with the limit. So we end up with 1 plus 2 over n plus 1 over n squared divided by 4 plus 6 over n plus 1 over n, or 2 over n squared rather. As I apply my limit, because from Calc 1, we know that that goes to 0, we know that goes to 0, we know this goes to 0, we know this goes to 0. So we are left with our limit, L, okay, is equal to 1/4, okay? We know that 1/4 is definitely smaller than 1, so we've compared it to 1. That's kind of the whole goal of the ratio test, is to compare it to 1. So since 1/4 is less than 1, we're going to say this converges absolutely by the ratio test. Okay, and that's how you do a problem like that. Okay, so again, when you see factorials that should scream at you, use the ratio test. All right. If you have a whole bunch of powers, then you can try the root test, but the ratio test is going to frequently be more helpful than the root test. Okay. So yeah, if you only are going to ever remember one, remember the ratio test. That's what is probably going to be more useful for more things. Okay. Thank you very much for watching my video. I'll see you in the next one. Take care until then.